Okay, in today's video, we're going to talk about the electrical fundamental codes in design. So we're going to go over things like the NEMA receptacle types. They will be discussed. The rules on GFCI receptacles and tamper-proof receptacles. GFI stands for ground fault circuit interrupters. The requirements on AFCI breakers. These are arc fault circuit interrupter breakers. Then we'll talk about NEC rules to receptacle placement for residential units. NEC stands for National Electric Code. The electric panel clearance requirements will also be discussed. We'll also discuss dedicated electrical space, which deals with the clearances that you need to maintain above electrical panels. Then we'll talk about prohibited locations for electrical overcurrent protection. So these are things like the electrical panels. Here is a list of some of the NEMA receptacle types. And NEMA is just a standard. It stands for National Electrical Manufacturers Association. So these are the standard NEMA types. You have a NEMA 15R right here. And the R stands for receptacle. So the plug, the standard would be a NEMA 15P for the plug that fits into this NEMA 15R. And this is for voltages that are 125. And 125 also can be 120 volt, which is the standard voltage used in the US. Next, you can have something like a 250 volt NEMA receptacle, and they basically start with this 2. So here it starts with 1 for the 120. For the 250 volt, it starts with a 2. So these are NEMA 2-15P. 15 stands for the amperage. So then you can also have this NEMA 220R, and the 20 stands for the amps again. So this is a 20 amp rated receptacle. And you could see the shape is a little bit different. So you are unable to plug accidentally a plug that fits into this one into the 20R. And that's the reason for the different shapes. So this 250 can also be rated for 208, which is a standard voltage in the US as well. So the standard voltage in the US would be 120 volt or 208 volt. So this 250 will work with this 208, and this 125 volt up here will work with the 120 volt. You also have this NEMA 5-15R. So this is a 15 amp rated plug. These are the most common types in the US right here. And it's because you have, if you look closely, you could see there is 3 openings here. So you got one opening here, one opening here, and here. So this one at the bottom is the ground input. So it's the same thing as here. These are the common ones, the NEMA 15R or 20R. So you have the 2 openings here. One would be the hot, one would be the neutral wire, and then this one would be the ground. So you can also have this 20 amp rated NEMA at this 125 volts, and the shape again looks a little bit different. You can see it comes with a horizontal opening here. So the difference in shape is so that somebody cannot accidentally plug in a 15 amp rated plug into this 20 amp rated plug here because the opening is different. So if a 20 amp rated plug was trying to be put into this 15 amp rated receptacle, it wouldn't fit. Now, if it was allowed to fit, then this 20 amp rated appliance being plugged into this 15 amp, it can actually trip the breaker because let's say it's drawing 20 amps, but the breaker on this 15 amp receptacle is 15. Then the 20 amp may trip the breaker. Now, if you go the other way and you plug a 15 amp appliance into a 20 amp, then it's possible that the 20 amp breaker potentially may not be protecting the 15 amp rated appliance. And that's the basic idea of these different shapes. allowing only a certain type of plug to be plugged into the receptacle. You can also have a combination 15 and 20 amp rated. So it'll be a combination of this vertical and this horizontal piece. So if you look on the right here, this is what that looks like. So in this, you can plug a 20 amp rated plug into this because it's horizontal here. You can also plug in a 15 amp rated plug since you have the vertical piece here. So according to NEC, you have to put these NEMA rated receptacles to a breaker that matches the amps. So for these 15 amp rated NEMA receptacles, you need a 15 amp breaker going to this. And for these 20 amp ones, you need a 20 amp breaker that feeds the receptacle. So the NEC requirement is that you have to match the amperage of the circuit breaker to the amp rating of the NEMA receptacle. You can put a 20 amp rated breaker onto a 15 amp rated NEMA receptacle as long as you have two or more 15 amp outlets on that circuit. So that's why you can also put a 20 amp on this NEMA receptacle here that allows for 20 amps as well as 15 amps because of that rule where you can apply a 20 amp breaker to a NEMA 15 rated receptacle as long as you have two of those 15 amp rated receptacles on that circuit. I also wanted to go over a common NEMA receptacle that's used for electric clothes dryers, which is called the NEMA 1430P. So this one has this voltage here. You can see there's a slash here, so 125/250 volts. So it actually has two of them. So if you look at the shape of it, there's four openings here where one of them is a ground, one of them is a hot, the other one is a hot, and one is a neutral. So with the hot and a hot, you have a neutral and a ground. So it basically makes a connection between the two hots to get the 208 volt. It uses one of the hot legs to the neutral to create the 120 volt or the 125 volt stated here. And it has a ground. So this is the common receptacle used for electric clothes dryers. So this is the section that talks about ground fault circuit interrupters, or GFI or GFCI. And the latest code at the time of this video is 2011 for New York City, and it's the 2011 NYC Electrical Code. And the New York City Electric Code is based on the National Electric Code of 2008. This section right here, 210.8, is the section that deals with the GFI breakers and where it's required. So if you read through this, it'll give you all the requirements, and they're basically required in areas where there's a water hazard. So in areas such as bathrooms, outdoor areas. They also have it for crawl spaces at or below grade level, grade meaning the sidewalk, unfinished basements, and if you go through this, other than dwelling units. So this section here is only for dwelling units, and B here is for other than dwelling units. You need it in these areas here: bathrooms, kitchens, rooftops, outdoors. So generally all in areas where there's a water hazard. If you also look here for laundry, utility, and wet bar sinks, where receptacles are installed within 6 feet of the outside edge of a sink, you will need a GFI receptacle. So the purpose of a GFI receptacle is basically to trip the circuit or the power to the appliance if there is some sort of electrical leakage out of it. So if there's some sort of water, there's a chance that the appliance being submerged in the water can cause an electrical leakage through the water into someone, potentially electrocuting them, and also potentially killing them. So you want to automatically trip the breaker in that condition. So the way it works is you normally have the power running through here, right? Basically out into the appliance and back through the neutral and back out. So if, let's say, this appliance was submerged in water and there was somebody in the water, or maybe somebody's just touching this and the person is touching a metal pipe or something like that that is grounded. So now some of the current is flowing through the person. In that case, the amount of current that's flowing through this sensor here is going to be different. So let's say you have 5 amps going out, 5 amps coming back in a normal condition. If it's leaking through somewhere else, such as a human, then you're going to get 5 amps going out, let's say 1 amp through the human. Then what's returning back is going to be, instead of 5, it's going to be 4. So this sensor is going to sense the imbalance and automatically open up the power in the receptacle so that now no more power is going out of the receptacle, and then any leakage current through a person would be disconnected. So that's how this GFCI receptacle works generally. Another NEC rule is for arc fault circuit interrupter. So these arc fault circuit interrupters, AFCI, are required in dwelling units based on section 210.15b. So it reads, dwelling units, all 120 volt single phase 15 and 20 amp branch circuits supplying outlet installed in dwelling units, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas shall be protected by a listed arc fault circuit interrupter combination type installed to provide protection of the branch circuit. So basically, in all parts of the dwelling unit, you need an arc fault circuit interrupter, except for areas such as the kitchen and bathroom, which requires a GFI receptacle. So what do they mean by combination type arc fault circuit interrupter? So an arc can be a parallel type arc or a series type arc. So a parallel is basically moving from one wire to another, whereas a series arc is basically arcing from that same wire just across. And a combination type, which is what the NEC requires, basically handles both of those type of arcs, the parallel type and the series arc. So these AFCI breakers basically look something like this on the bottom, and it fits in a electrical panel, just like a regular circuit breaker. The only difference is it has this neutral wire that also has to be connected to the neutral bus bar. And this is what an arc fault circuit interrupter breaker looks like. And the reason for these AFCI breakers is to prevent the potential of fire. So fires can start from an arc because the arc actually generates a very high temperature that if it then makes contact with, let's say, a window curtain or anything else that is flammable, the high temperature of the arc can be a potential source of fire, and that's the reason for this AFCI requirement. So the NEC has rules for the placement of receptacles and basically where they are required, and mainly they're for dwelling units. For commercial spaces, there are no real requirements for receptacles, but for dwelling units, there are. So we're going to go over all the requirements for receptacle placement in dwelling units. Those requirements are basically in the NEC, section 210.52, and the receptacles shall be installed such that no point measured horizontally along the floor line in any wall space is more than 6 feet from a receptacle outlet. So basically, you would have to space them 6 feet from a wall or 12 feet max between receptacles. You can also have wall spaces that are 2 feet or more in width. You would basically consider it a wall space and you would have to provide a receptacle there. And things such as fixed panels, such as exterior walls like sliding windows, if there's a fixed panel, you would basically treat it as a wall. And also, if there is a railing that is fixed, you would also treat that as a wall space. So here it is, freestanding bar type counters or railings would basically be considered a wall space. Now you could have floor receptacles that will go towards this required receptacle placement only if it is within 18 inches of the wall. You also need receptacles on kitchen countertops, pantries, breakfast rooms, dining rooms, and similar areas. And there's also a requirement right here where if you have some type of sink or a range or some type of equipment where there's a 12-inch distance behind it to the wall, then you don't have to consider it as an obstruction. But if there's less than 12 inches behind that range or appliance or sink, then you basically consider that as an obstruction that divides that countertop space. So then you would have to treat those two separate sections as countertop spaces and place the receptacles in those locations if they're required. And for countertop spaces, a receptacle outlet has to be placed in any section that's 12 inches or wider. And the receptacle outlet shall be installed so that no point along the wall is more than 24 inches measured horizontally from a receptacle outlet in that space. So basically 2 feet from a wall or 4 feet between receptacles max is how these countertop receptacles should be spaced. So here are some pictures that demonstrate some of the code requirements that we just read about. So these are the kitchen countertops here. And if you look at this distance here, so this is a sink. And if this X distance is less than 12, you would basically consider this as an obstruction here. And then these two pieces as wall sections where you need the receptacle. If this X was 12 inches or more, then you would consider this whole section here as a wall space. And then you would have to space the receptacles maximum 2 feet from a wall and 4 feet between receptacles. For a corner type sink here, the rule here seems to be 18 inches or less. You would consider this as an obstruction and this part splitting the two wall countertop sections here. Now, if it was 18 inches or more, then you would consider this not an obstruction. And you would basically consider this one continuous countertop section where you would have to space the receptacles 2 feet from a wall and maximum of 4 feet between receptacles. So there's some more rules for receptacle placements in section 210.52. So we'll go over them right here. So the island countertop space, at least one receptacle shall be installed at each island countertop space with a long dimension of 24 inch or greater and a short dimension of 12 inch or greater. So an island countertop is something like this. It stands all alone. And if you look at this one, peninsular countertop spaces, that's something like this. So if this is the wall right here, a peninsula is basically, this is the connecting edge, and it basically extends out. So there's no walls on any of the sides of the peninsular countertop. And for an island type, no walls surround any of the four sides of the island countertop. So for a peninsula countertop, at least one receptacle shall be installed at each peninsula countertop space with a long dimension of 24 inch or greater and a short dimension of 12 inch or greater. So if we look here, you could see that this is 24 inches and you need it if it's 12 inches or greater on this side. And typically for a kitchen, this is a standard 24 inches or so. So you only have to consider kind of like this area here being more than 12 inches to basically be considered a space that requires a receptacle. So if you have things that are separating the spaces, such as by refrigerators or range tops, you consider that as separating the countertop spaces. Receptacle outlet location. Receptacle outlet shall be located above but not more than 20 inches above the countertop. Receptacle outlets rendered not readily accessible by the appliances shall not be considered as these required outlets. So you just have to make sure that if this is a countertop, this is 20 inches above. You want to keep the entire receptacle below that 20 inches to be considered as counting towards these required receptacles. When you have a receptacle for a peninsular countertop or an island countertop, you have to make sure that the receptacle outlet is mounted no more than 12 inches below the countertop. And receptacles mounted below a countertop in accordance with this exception shall not be located where the countertop extends more than 6 inches beyond its support base. So basically what this means is what this rule means basically is if you have a peninsula countertop such as this picture here, the receptacle is located from the top to the bottom of the receptacle cannot be more than this 12 inches here below the countertop. So here to here should be no more than 12 inches. And this exception here shall not be located where the countertop extends more than 6 inches beyond its support base. So if this extended more than 6 inches beyond this point here, then this receptacle wouldn't count. All right, so here are some more requirements for receptacles. You need outdoor receptacles for 1 and 2 family dwellings. Basically, you need one receptacle at grade level and located not more than 6.5 feet above grade shall be installed at the front and back of the dwelling unit. Now, if you have a multifamily dwelling, which is considered 3 or more families, you need one receptacle outdoors for the dwelling unit that is located at grade level and provided with an individual exterior entrance. You need to put at least one receptacle 6.5 feet or below above grade. You also need one for balconies, decks, and porches that basically have at least 20 square feet. And they also have to be located 6.5 feet or below. Laundry areas also require at least one receptacle outlet, basically for each dwelling unit, and there's some exceptions to that. And the exceptions are, if it's a multifamily building with a public laundry area, you're not required to put a receptacle there. And other than one family dwelling units where laundry facilities are not to be installed or permitted, a laundry receptacle shall not be required. You also need them in basements and garages for one family dwellings. You need at least one receptacle in each basement and in each attached garage. Where a portion of the basement is finished into one or more habitable rooms, each separate unfinished portion shall have a receptacle outlet installed in accordance with this section. For hallways that are 10 feet or more in length shall have at least one receptacle outlet. And the hall length shall be considered the length along the center line of the hall without passing through a doorway. So it has to be unobstructed for 10 feet. And in that case, if it's 10 feet or more, you would need a receptacle in that hallway. For HVAC equipment, you do need at least one 15 or 20 amp rated receptacle located within 25 feet of the heating, air conditioning, and refrigeration equipment. So this receptacle cannot be installed on the load side of the equipment disconnect means. So if you have power coming into a disconnect, and this is going to your AC unit, this will be the load side, and this would be the source or the power side, and you are not allowed to connect it to the load side of the disconnect means, because this receptacle here is meant to service the AC equipment. So if somebody is servicing the AC equipment, they would cut the disconnect and the power to the AC equipment, and if the receptacle is on the load side, you would not be getting power to the receptacle, and therefore this receptacle should be connected to the power source, so that with the disconnect off and the power off to the HVAC equipment, you would still be able to service the AC equipment through this receptacle. So here's a picture that will help summarize what we just talked about. If you look on the left picture here, so for a room in a dwelling unit, you need a receptacle along unbroken walls that will be no more than 6 feet from the wall to the receptacle. So you could see, following the direction of the wall, it has to be 6 feet or less. And also here you could see it's 6 feet or less. Now, this operable sliding door is not considered a wall, but this fixed glass portion is. So you would consider this portion here as a wall. So you have to place a receptacle no more than 6 feet from this point to the receptacle. And then the distance from here to here is less than 6 feet. So you're okay with just one receptacle here. This wall segment is 2 feet or more. So if you look here, if the wall is wider than 2 feet, so 2 feet or more, you would need a receptacle. So that's why they placed a receptacle here. Here again, you put another receptacle. And for this place, for this segment of the wall, you're going to get more than 12 feet. So you're going to need more than one receptacle. And each receptacle cannot be placed more than 12 feet apart. So the distance is a max of 12 feet between receptacles. And here the wall, basically distance is considered wrapping around this wall to this point here. So it has to be 6 feet from this point. Looking at the picture on the right, this is for a dwelling unit kitchen countertop. So any countertop space that's more than 24 inches, this is 24 inches, and 12 inches requires one receptacle. So we have one here. The refrigerator, this one is just for the refrigerator. Okay, so this wouldn't really count towards countertop receptacles. These countertop receptacles have to be a maximum of 24 inches from the edge and maximum of 4 feet between receptacles. This distance here is to the edge of the sink, so it seems like they're not considering this a countertop wall. They're not considering this as a countertop space, and that's probably because the distance from here to here is going to be less than 12 inches, in which case you would have to consider this as being separate. Now, if it was 12 inches or more, as stated here, so it's exempt if it's less than 12, so 12 inches or more, you consider this as a wall space. So if this was 12 inches or more, it would be considered a wall space, and then you would need, let's say, another receptacle somewhere in this region here. If, let's say, it's more than 24 inches from here to, let's say, here, right? Because the maximum distance between a receptacle would have to be 4 feet. So here you have 12 inches or more, which would be considered a countertop space that requires at least one receptacle. So they place the receptacle here in this section here. For the peninsula, from the connecting edge, if it's 24 inches in one dimension and 12 inches or more in another dimension, you need a receptacle. This receptacle could be mounted on the side of the peninsula, no more than the 12 inches below the countertop surface of the peninsula countertop surface. For the island, again, if you have a section that's more than, if you have a section that's 12 inches or more, and the other dimension, which is 24 inches or more, in this case it's 36, you would need one receptacle, and the receptacle would be located no more than 12 inches below the surface of this countertop. And you have another section here that also is more than the 24 inches on one dimension and 12 inches on the other dimension. So you would also need a receptacle for this section here. And if X is less than 12 inches, these two sections would be considered separate areas because of this obstruction. So if this X was actually 12 inches or more, this section here would be considered an obstruction, and this whole space would be considered one continuous section. In that case, you don't actually have to follow the same requirements of spacing the receptacles 2 feet from a wall and 24 and 4 feet between receptacles, because it's not a wall countertop in this case. If you look back at the code section, you will see that for island countertops, you just need at least one receptacle on each side of the island countertop with a long dimension of 24 inches or greater and a short dimension of 12 inches or greater. It doesn't mention that you need one at a maximum of 2 feet from a wall or 4 feet between receptacles. Same with a peninsula countertop space. It just mentions at least one receptacle shall be installed at each peninsula countertop space with a long dimension of 24 or greater and a short dimension of 12 inches or greater. And if you look at the other code section here, but for wall countertop spaces, you see this requirement for the receptacles being no more than 24 inches. You can see this requirement here stating that receptacle outlets shall be installed so that no point along the wall is more than 24 inches measured horizontally from a receptacle outlet in that space. So that means that if you have a receptacle here, the next receptacle would have to be no more than, you got 24 inches and 24 inches. So between the receptacles, it cannot be more than 4 feet max between receptacles. But this requirement is only for wall countertops, not for island or peninsula countertops. So if this distance from here all the way to here was, let's say, 4 feet to this point, and then 4 feet to this point here, you wouldn't need to place a receptacle right in this location because this is an island countertop. So for this peninsula space, if the distance between this receptacle all the way to this was more than 4 feet, so let's say it was 5 feet, you wouldn't need another one in between those because they don't follow the rules required for wall countertop receptacles. All right, so here's a picture of an elevation just showing the heights location for walls, floor receptacles, as well as the countertop receptacle here. So the wall switch anywhere between 4 feet to 52 inches. Floor receptacle to the center line of it should be approximately 12 inches to 18 inches. And the center line of the countertop should be about 4 feet, 3 to 4 feet above finished floor to center line. And the countertop should be no more than, and the countertop receptacle should be no more than 20 inches above the countertop surface. Right here should be no more than 20 inches. There's some other requirements for clearances for electric panels and equipment. So you need service clearance for the panel. You need 6.5 feet from floor to the top, 3 feet in front, and 30 inches in width. And that 30 inches can start from here and move this way, or it can actually start from here and move this way, or it can just be centered where you have 30 inches and the panel is centered in between the 30-inch clearance requirement in that 30-inch width requirement. You also have a dedicated space requirement, and that's right here. So the code basically states in section 110.25F a dedicated space requirement. So this is the space equal to the width and depth of the equipment and extending from the floor to height of 6 feet above the equipment or to the structural ceiling, whichever is lower, shall be dedicated to the electrical installation. No piping, ducts, leak protection apparatus, or other equipment foreign to the electrical installation shall be located in the zone. Exception: suspended ceilings with removable panels shall be permitted within the 6-foot zone. So this is the 6-foot zone extending above the electrical equipment. So following the area of this equipment, extending straight up 6 feet is considered the dedicated electrical space. So nothing other than the electrical equipment can be within this space. So electrical equipment can be conduits that basically run into, this equipment here. And nothing other than electrical equipment can be within this dedicated space. You can have a suspended ceiling, so basically a drop ceiling that goes within this 6 feet, but you wouldn't consider that as a structural ceiling, which is basically, but it would be considered a structural ceiling, which is basically like a concrete slab or metal deck. B. Foreign systems. The area above the dedicated space required shall be permitted to contain foreign systems, provide protections installed to avoid damage to the electrical equipment from condensation, leaks, or breaks in such foreign systems. So above this, you're allowed to have the foreign systems as long as you have some sort of protection, such as a pan that could collect any breakage of water pipes, for example, from dropping onto the electrical equipment, or any type of condensation. So if you have cold water piping, it's possible that you could get condensation on that cold water piping, which could drip down to the electrical equipment and cause some issues there. So you would need to provide some protection for any potential leakage for objects that are above this dedicated electrical space. Sprinkler protection shall be permitted for the dedicated space where the piping complies with this section. So in this picture here, you see the piping is here. And you are providing sprinkler protection because this spray actually will extend to this wall, providing protection to this dedicated electrical space. But the piping still needs to comply, meaning it has to be away from this dedicated electrical space zone as well as above it. And if it is actually above the dedicated space, you would just need to provide some sort of protection against any leakage or condensation. D. Suspended ceilings. A dropped, suspended, or similar ceiling that does not add strength to the building structure shall not be considered a structural ceiling. So anything like a drop ceiling that you typically see in offices would be considered this type of suspended ceiling. Now, there's some locations where the electrical service panel and equipment is not allowed, and these areas are covered in this section, and they are not in vicinity of easily ignitable materials. So overcurrent devices shall not be located in the vicinity of easily ignited materials, such as in closed closets. So it's prohibited in these type of closets here. Not located in bathrooms. So in dwelling units and guest rooms or guest suites of hotels and motels, overcurrent devices other than supplementary overcurrent protection shall not be located in bathrooms. So basically, you would not put any electrical panels in bathrooms. That would be prohibited. Not over steps. Overcurrent devices shall not be located over steps of a stairway. So these are mainly the three areas that electrical panels should not be located in. And that concludes this video.